Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the lecture number 3 for your course of Communication Technology. My name is Engineer Jaffar and I'm instructor for this course. So let's start with the discussion of today's agendas of today's lecture. So today's activity will be regarding about the modulation, which is a important process, or you can say phenomena that is involved while processing your communication network. So once the one of the processes is basically known as modulation, and the inverse of that is basically demodulation. Mostly you have heard about hardware device that is basically modem. So modem is nothing but a combination of the modulator and demodulator. Modem means modulator and demodulator, so it's a combination of both of these processes. The process is done by the modem. So we will discuss about the modulation, that what actually is modulation, what is the motivation behind this process, why do we need to use it in our communication network. And in the second part we will discuss about the types that are of the modulation. There are several types. It is not possible for anyone to learn these types all in once, so I have divided the course like in such a way that you will be able to learn all these types, if not all, most of these types in the following lectures. And after that we will be discussing about the inverse process, that how this modulation is basically inversed or cancelled at the receiving end side by the use of a demodulator, and the process is known as demodulation. So let's get started with the phenomena, that what is actually the modulation. So in modulation, a message signal, basically we will discuss about all these terms one by one. So let's go with the definition first. So in a modulation, a message signal, that is a low frequency signal. Most of the time this message signal is normally termed as baseband signal. Baseband signal, and this baseband signal has a frequency of very low frequency, a very low frequency, and this basically is mostly generated by a natural source, just like I'm talking to you right now. So my voice is basically a message signal that has some information in it, and I want this message to be transmitted at a larger end at a far distance. So I have to use a carrier signal. This carrier signal, and this carrier signal is basically a sinusoidal signal which has a high frequency. So this has a high frequency, and the baseband signal has a low frequency. So this is basically a difference between the frequencies of both of these signals, the message signal and the carrier signal. So this is the process, and this is known as modulation. So let's talk about the terms that are involved in these as definition. So a message signal, mostly this signal is normally termed as modulating signal. That signal that you want to modulate is known as modulating signal. So mostly it is either analog. If it is analog signal, it is denoted by M of T. You will find this M of T in your books, in your textbooks that I have discussed with you in the first lecture actually. And if the message signal is digital, so this signal will be termed as D of T, because this is if the signal is digital, so you know that digital signal is composed of the sequence of ones and zeros. So this is the frequencies, this is the representation of these message signals that are involved in the modulation. The message signal could be of two or more levels. Let's say if it is analog signals, for instance, let's say, so it is possible that you have more than one level. So let's say this is one level, this is level number 2, and this is level number 3. So you see, there are more than 2 levels. It is also possible to have 2 levels. It is also possible to have multi-level. So these two are the combinations. It is not compulsory that the signal should be binary. It could be composed of multiple level signals. So we will discuss that in in the coming lectures, inshallah. So don't worry about that. We will start with the binary signal and we will take it to the further level, and you will see that how these signals are basically modulated if they are multi-level signals. So the next thing is basically the carrier. The carrier, as I have told you, that the carrier could be a sine wave or pulse train. Mostly the sine wave is representing all the sinusoidal signal. It can be cos or any other variant of sine wave, because you know that cos is nothing but the, you can say, the delayed version or a shifted version of sine wave. And so it could be any sinusoidal signal depending upon the implementation, that how you implement it. So you know that this is a representation of a sine wave which has a, you can see the you can see that it is basically cos function, but it has some phase shift in it. So that is why we call it sinusoidal wave. So it could be any wave, any sinusoidal wave, but the only condition is that it should have a high frequency, because it is the only reason why we are trying to superimpose this baseband signal on this carrier signal. So let's summarize that what we have discussed till now. So the baseband signal, when is superimposed on a carrier signal, I repeat again, when a baseband signal of low frequency is superimposed on a high frequency carrier signal, so this process is known as modulation. So you can see that if this message signal controls the amplitude, we will discuss these types in coming slides and as well as in the coming lectures in very much detail. So don't worry about these following slides as well. You will learn it slowly and gradually, inshallah. So if the message signal's m of t controls the amplitude, so it gives a amplitude modulation. And if the m of t is controlling the frequency, so it will generate a frequency modulation. And if the message signal is controlling the phase, so it will give a phase modulation. You can see that in this equation, you are basically you can control three things. One is the amplitude. This is the amplitude. Let me label it. This is the A for amplitude. And this is your frequency, angular frequency omega, and you know that is equal to 2 pi f, and this f is nothing but your linear frequency. So this is your frequency and this is your phase. So if you are manipulating or controlling, this is your phase, sorry, P. So if you are controlling the amplitude, you are doing amplitude modulation or AM. If you are trying to control this f, so basically you are doing a frequency modulation. And if you are trying to control this phi, or you can say phase, using this m of t, you are doing a phase modulation. So what's the difference between analog and digital? So in digital modulation, the amplitude modulation is basically shifted into the amplitude shift keying. In the analog it was amplitude modulation, and in the digital terminology, when the signal is digital, it converts into amplitude shift keying. When you control the m of t, you control the amplitude with the m of t in the digital signals. So basically this d of t is you can say that it is basically modulated in a way of ASK. Similarly, if you control this signal with d of t using this frequency, so it becomes sorry, this is the thing, frequency shift keying. So if d of t controls frequency in the in m of t, which was analog, if you remember, if you controlled amplitude, it was AM, and in a digital d of t, if you control amplitude, it becomes ASK. Similarly, in m of t analog signals, if you control frequency using FM, you are doing a frequency modulation. And in d of t, if you are controlling the frequency using this d of t, so it becomes FSK. And similar with the phase. if you are controlling the modulation or signal in M of t using the phase, so it was phase modulation. And in digital terminology, if the signal is controlled with a phase thing in the digital signal, so it becomes phase shift keying. We will do all of these in with examples and their proper explanation in the coming lectures, inshallah. So this is the summary of this slide, and you can see that as I've told you, that it could be binary and it could be higher, more than 2 level, or you can say multi-level. So if it is binary, you can see that there are only 2 levels, 1 and zeros. You can see that there are only 2 levels. If in this discussion you can see that D of t is binary or 2 levels signal representing ones and zeros, and we'll discuss that how you can increase the level, multi-level, but that is not in digital format, it is on the waveform. So you will be seeing different waveform, how you can manipulate these bits into multiple level, and you will love it, inshallah. So there are mainly 3 types of digital modulation: ASK, FSK and PSK. Now if it comes to the multi-level, so you know that this was 1 and 0 in the form of 1 and 0. You cannot create more levels. If you want to create another level, because let's say this was level 1 and this was level 0, this was 1 and this was 0. So if you want to create another level, let's say this level, so it should be named with some other binary data. So for that you have to go with another name, let's say double 1. So you just increased the bit number to denote a level. So this is how you basically increase the complexity of your communication network when you increase the bits number. So you can see now you can have multiple levels: 00, 01, 10 and 11. And how you basically term these, we will be discussing that. So don't worry, this is just introduction class for the modulation, and we will be covering, I repeat again, we will be covering all of these topics one by one in each and every lecture by the end of this till the end of this course. So you have to be patient and consistent. So these are in this diagram I've shown you the 4 levels. So here the M is equal to 4. You have 4 levels for the modulation or demodulation. So in this case you can see there. So the one thing that you have to remember, that if you want, these are code words, these things are code words. So if you want to have 5 levels, so you have to go with the formula of this. You cannot have 5 levels, because if you add 1 bit over here, so it becomes 3-bit combination, 3-bit code word. So you know that if you are using 3-bit code words, the possible combinations you will be having is of 8. So it only runs in the power of 2. So you can have 2 power 0 levels, that is 1 level. You can have 2 power 1 level, that is 2. You can have 2 power 2 levels, that was in this diagram, that is 4. And you can have 2 power 3 levels, and up to so on. As long as you want to increase the levels of this message signals, you will have to increase the code words length, and that basically increases 2 things. The first thing is the complexity level. You are nothing but increasing the complexity level of your code words and your communication network. And the second thing that is increased is basically the energy transmitted per bit. Energy per bit. So it is, these are some disadvantages of going with the energy per bit, because you know that it is less energy consumption required when you are trying to send only 1 or only 0, and it is much more energy consumption, or you can say there is much more energy consumption when you're trying to transmit 2 bits, let's say, or 3 bits. so you just have to increase your energy, and that increases the energy consumption. So these are two major drawbacks of increasing these levels, but the only advantage, or you can say the gain that we gain from this doing such a thing, is basically the less error possible, less error ratio. You are getting closer and closer at the receiving end side. When you receive a message and you have multiple level, you can easily detect what type of message it was from the transmission end. So let's go in depth that what is this code word, and we will be discussing this all this. I told you that we will be discussing these analog. We will start with the analog and we will hit towards the digital from the coming lectures, inshallah. So this is you can see there are 4 levels. So this 4 level PSK is basically known as QPSK, or quadrature phase shift keying. So let's talk about the reverse process. This is known as the demodulation. So in the modulation, you basically you see that this is the modulation side and this is the demodulation side, and this is you can say this is the transmission end side and this is the receiving end side. So in the modulation, we basically superimpose our message signal, either it could be analog or it could be digital, with a high frequency carrier signal, and we then transmit it through a channel, and at the receiving end the receiver receives it and it gives it to the demodulator, and that demodulator again regenerates that original signals, or it try to regenerate that original signal as close as possible to the respective transmitted signals using some rules. So this reverse process of modulation is known as demodulation. So demodulation is the reverse process to recover the original message signal M of t or D of t at the receiver end, so that it is most correlatable from the transmission end side message signal, that was M of t or D of t. So this is known as the demodulation process, and the phenomena or the device that is known as that is used for this process is known as demodulator. So mostly these two are embedded on the transmission end side as well as the receiving end side, and this is combined by the name of modem. If you have heard of this term, modem. So modem is a combination of this modulator and a demodulator. It is a single device that do the whole process, because for the first instant you may be the transmitter, but at the second time you are the same device is basically a receiver. So you have to have both of this modulator and demodulator, and for that you need a single device, and that single device is known as modem. So let's summarize our lecture. There are several you can see that these are the modulation techniques. If this is your message signal or modulating signal, or you can call it a baseband signal with a low frequency, and I will write BB, basically known as baseband, and you provide it into the modulator and it shift it into modulated signal. For here the signal was not modulated, it was modulating, and here the signal is has completed the modulation, so it is modulated signal. Similarly, if your message could be analog or digital, if it is analog, you denote it by M of t. If it is digital, you denote it by D of t, and you provide it to the modulator, and it provides you multiple schemes. You can have multiple modulation techniques, and you have a carrier with it. You multiply your carrier, you superimpose your carrier onto this baseband signal using a modulator, and you can generate, if you want to if you are trying to change the amplitude, so you can have this much of combination in the amplitude. If your signal was analog, you can have double sideband amplitude modulation. single sideband amplitude modulation, double sideband with suppressed carrier, and single sidebands with suppressed carrier, and it was some of where the carrier was dimmed. Double sideband with the carrier is diminished, and single sideband with the diminished carrier. Similarly, if the message signal was digital, so it was amplitude shift keying, or you can also call it on off keying, and there are several other names like PSK and PRK. So this all these terminologies I will be teaching you all of these, not all of these, not just these. There are more a few more. Let's say if you are using a modulation technique to using the frequency modulation, you are trying to change the frequency, so you are basically doing the frequency modulation. So in the analog terminology, you will call it FM, that is frequency modulation, and there are two further types of FM: WB-FM, that is wide band FM, and NB-FM, that is narrow band FM. And if your message signal was digital, like say D of T, so you will be getting FSK. If it was M of T, you have your FM or any of the types, WB-FM or NB-FM, and if you had D of T, you will be getting FSK. Similarly, if your message signal was you want to try your phase to be varied instead of your frequency and amplitude, so the outcome will be PM, that is pulse amplitude modulation. So you have multiple varieties of modulation, and there are approximately 10 to 15 types that we will be covering in this course, inshallah. So there is a lot of things to learn, and don't worry about these terms. We will be discussing that when we hit this topic one by one in the coming lectures, inshallah. So this is your complete diagram for your modulation techniques, and there are some familiar applications, so you have to see it. For example, if you have this analog message carrier message signal, so you can have two types of things, that is the sine wave carrier, and the second one is pulse train carrier. So this is not involved in our course. We will be discussing we will not be discussing this part, though we will be discussing these terms in the digital concept as well. We will be discussing some of these, like let's say these things: sampling, quantization, etc., TDM, DEM. We will be discussing some most of these terminologies, but not in this phenomena. We will be discussing it in a digital signal, because it is an analog signal. We will be discussing these things in a digital signal. When the signal was digital, signal will be digital. So in the analog signal, when you are using sine wave carrier, so you will be having AM amplitude modulation or angle modulation. This angle modulation is could be of frequency and phase. And now there is a bonus point for you. My question to you guys is that why we call the frequency modulation and phase modulation as a angle modulation. So my question to you is what is the reason to call both of these as a whole as angle modulation and amplitude modulation as a different entity? So these two entities are combined under the umbrella of angle modulation, and amplitude modulation is separated from these things. So you have to answer me the reason behind this separation. And the angle modulation can be double sideband, single sideband with suppressed carrier or diminished carrier, and you can see that there is also mentioned their applications. For example, military amateur radio is basically a single sideband with carrier suppressed, and vestigial sideband is another type. It is used in the television. We will be discussing this thing in the coming slides, inshallah. And you can see that this is your a summary of modulation techniques with some derivatives and familiar applications. If your message signal is digital, let's say D of T, and it has a level of 2, or you can say binary, so you can have these types of modulation techniques, you can do it on them. So we will be discussing all of these inshallah, because you know that most of the communication networks nowadays are transferred or transmitted towards the digital, transferred to the digital technology. So I think that you should have a clear idea of all of these. So we will be discussing all of these one by one in the coming lectures. And if you go to the further levels of modulation, instead of binary or 2, you can have multi-more levels. M array, M stands for any level. You can call it 4, you can call it 8, you can call it 16, and nowadays they are doing things like 64 and 128. So this is not the limit, sky is the limit. And you know that the more you learn, the less you know. So this is all for today. I hope that you have learned quite a lot from the introduction of modulation, from the perspective of introduction to the term of modulation and demodulation. In the coming lectures, I will be teaching you how you can use this modulation actually, and how you can decide, and what are the deciding factors. We will be discussing the deciding factors or at the end, but I will teach you each of the technique, that how a technique is implemented, how you can actually implement this technique, each of these techniques, and what are the basic differences between each of these modulation techniques. So I look forward that you are available in the class to ask some good questions, because you know that the more you ask, the more you learn. If you are not able to attend the class because of any reason, you can also reach me at my email address that is mentioned in every slide of your lecture. I see you in the class. Thank you very much. Allah Hafiz.